Good morning students, welcome back to my channel The Science Station. Yesterday I discussed, or in previous video I discussed, the experimental illustration of uncertainty principle. Today we discuss Schrodinger wave equation. This is very important question. Before starting today's session, please like, share and subscribe my channel. If you have any doubt, any queries regarding to this session, please comment in comment box. Thank you. Shall we start? This is Schrodinger wave equation. What is a Schrodinger wave equation? It is the basic principle which cannot be derived from other basic principle of science. Means this principle is independent principle. According to de Broglie's theory, a particle of mass m, a particle of mass m moving with velocity v has wavelength lambda. So we can also write lambda equal to h upon p, where h is equal to Planck's constant. Okay. Momentum equal to mass into velocity. This is the equation number 1. So our equation number 1 is lambda equal to h upon p or h upon mv. That is our equation number 1. Now here, where p is the momentum of particle, but in classical physics, for a wave moving along x direction, the displacement y is given by y equal to a sine 2 pi lambda upon x. Already I told you a displacement amplitude. Amplitude means the maximum displacement. This one is amplitude. This one is amplitude. Amplitude will be the maximum displacement. Y 2 pi sine for wave. We express any wave notation in sine for sine theta 2 pi y 2 pi, because we have 360 degree, one circle 360 degree, lambda wavelength. Okay, this is y equal to a sine 2 pi upon lambda. It is equation number 2, where a is the amplitude, x position of coordinates, by wavelength, x because we are moving in x direction. An equation similar to the equation 2. See, de Broglie's wavelength also I said we can write psi equal to a sine 2 pi x upon lambda. Yesterday I told you what is the wave function. Wave function can be write in form of sine. This is equation number 2, equation number 3, equation number 2, and we have equation number 1. Now we differentiate equation number 3 with respect to 2. यहाँ पर हमें 2 times we have to differentiate equation number 2. What we get? d2 psi upon dx square equal to minus 4 pi square lambda square a sine 2 pi x upon lambda equal to, we can write 4 pi minus 4 pi square lambda square psi, because this function is psi here from equation number 3. So we get the equation like this. यहाँ पे आएगा, this one is यहाँ क्या, lambda square 1 upon lambda square equal to, see what happened, हमने सिर्फ ये नीचे आ गया 1 upon 4 pi square psi d2 psi upon dx square equal to 1 upon lambda square. Okay, again rearranging the equation, what we get? 1 upon lambda square equal to 1 upon 4 pi square psi d2 psi upon dx square. This is equation number 4. Now if particle is having mass, velocity, then the kinetic energy of particle can be write as 1 upon 2 mv square, or we can write p square upon 2m. Okay, how can write? I will show you. P equal to mv 1 upon 2 pi into mv square upon m. Same thing we have, okay na? So we can write like this, 1 upon 2 p square upon 2m. Okay, from here we get p equal to h lambda. We put the value of h square upon 2m lambda square. As if particle is moving in the potential v, then the total energy is the sum of kinetic energy and the potential energy. Kinetic energy p square upon 2m plus v, potential energy. Okay, now coming here, p square upon 2m, we just change the direction, e minus v. Here we have, we just v इधर आएगा, it becomes negative. Now from equation number 4, where we have the value of lambda, equation number 4 and equation number 5, by combining the equation number 4 and equation number 5, see, 1 upon lambda square we can write the value of 1 upon lambda square h square upon 2m as it is लिखेंगे और ये वैल्यू रख देंगे. I will show you. Ke equal to p square upon 2m, that is h square upon 2m lambda. What is the value of 1 lambda square? From this equation we have the value of 1 upon 4 pi. We get the value this, 1 upon lambda square equal to psi d2 psi upon dx square. Then we have p square upon 2m equal to h square upon 2m 4 pi square psi d2 psi upon dx square. Okay, this is the equation number 4, what we get here. So by putting value, this becomes 8 or h square upon 8 pi square, or we can write h square upon 8 pi, h square upon 8 pi square and 1 upon psi d2 psi del 2 psi upon del x square. See, सेम थिंग e माइनस वी इधर आ गया, पॉजिटिव हो जाएगा, और ये इधर चला गया, पॉजिटिव हो गया. वी राइट, ये साई यहाँ पे इंटू हो गया, बोथ साइड वी राइट, साई का इंटू किया, साई एंड साई ईयर. देन व्हाट वी गेट, अगेन rearranging the equation, we can write like this, minus h square 8 pi square m into 1 upon psi d2 psi h square equal to 1 minus v psi. Okay, psi cancel हो गया, we get this value. Here we have psi cancel हो गया, यहाँ पर आ गया माइनस प्लस d2 del 2 psi del x square plus 8 pi square m h square e minus v psi 0, where h is a Planck constant and the value of h is 6.63 into 10 raised to power minus 34 joule per joule second. This is the Schrodinger's time independent wave equation in one dimension. See, यहाँ पे time we don't have any time. This is the reason why we call this equation time independent Schrodinger equation. This one dimension, in 3 dimension we can write this x coordinate, y coordinate, z coordinate, and h upon 2 pi is h cross. In simplified form, dou 2 psi equal to 2m e minus v h cross psi equal to 0, where psi is equal to amplitude of wave function, x, y is in Cartesian coordinates, m mass of the electron, h Planck's constant, e total energy, and v is equal to potential energy. This is very important derivation, Schrodinger's time independent wave equation. Next term I will show you only free electron theory. This is the Schrodinger time equation. If you want, please write and do it once. You can easily understand the, and Please be with me, like, share and subscribe my channel, The Science Station. Thank you. Thank you so much.